Well, we have another question here. The question says, consider the quadratic sequence 72, 100, 120, 132. Determine Tn, the nth term of the quadratic sequence. Well, I am going to write the question over here. So we're doing question 2.1. 2.1, we have the quadratic sequence like 72, 100, 120, and 132. Now, because 2.1, I want to say 2.1.1 here, 2.1.1, we are looking for Tn, okay? Now, because the question says that it is a quadratic sequence. Quadratic sequence, we know that it is of the form Tn equal to an squared plus bn plus c. Now, from this formula, we can derive some sub-formulas, okay? A, for instance, equal to the second difference over 2, okay? And then b, not b, but I'll write here 3a plus b equal to the difference between T2 and T1. And then a plus b plus c equal to T1. Now, over here, let's first find the second difference, okay, between the terms. So I prefer to do them here. The first difference will be linear, so there will be like 100 minus 72 is equal to 28. Okay, 28, and then 120 minus 100 is 20. 20, and then 132 minus 120 is equal to 12. Now that's the first difference. Now the second difference, okay, I want to do 20 minus 28, which is -8, and then 12 minus 20 is -8. So this is the constant difference, D2. I call it like that. I call it D2. Now we can substitute this over here. So it's going to be equal to -8 over 2. Then A will be equal to -4. Okay. And then we also have here 3A plus B equal to T2 minus T1. T2 minus T1 is just the difference between, T2 minus T1 is the difference between 172, which is 28. So I'm gonna write here its value, 28, and then A is -4, okay? T2, because T2 is 100 and T1 is 72. 100 minus 72 is 28. And then let's work it out. This will be equal to 3 times -4 is equal to -12 plus B equal to 28. So if I move the -12 over, it becomes +12, then B will be equal to 28 plus 12. This is equal to 40. Okay, we have A, we have B. Now we can also work out C. Because we know the value of A, B, and C, A and B. I can just move my board like this. We will substitute those values over here. Okay, so we have like C will be equal to A is -4, so -4. And then B is 28, actually 40, I meant 40. And then T1 is the first term here, 72. So T1 will be 72. Now, to work out C, we have like -4 plus 40 is 36 plus C equal to 72. So if I move 36 over, I will have 72 minus 36. That makes C will be equal to 36 also. So now we have A, B, and C. We can work out. Now we can write the quadratic pattern Tn. Tn will be equal to -4 n squared plus 40 plus 36. So that's Tn. Good. The following question is 2.1.2. The question says that a term in the quadratic sequence 72, 100, 120, 130, 132 is equal to the 12th term of the sequence of the first difference. The first difference is determine the position of this term in the quadratic sequence. All right. Well, I'm going to move my board over here. Split it like this. So let's 2.1.2. So we are looking for a certain term n, okay, Tn, okay. Well, we need to find n such that T12, okay, or I'm going to say T12 in the quadratic sequence is equal to, okay, let's read the question over again. It is said that a term in the quadratic sequence, okay, is equal to the 12th term of the 12th term of the sequence of the first differences. So we need to find that term now. Okay. First of all, yeah, let's get back here. Tn, we know Tn here is -4n squared plus 40 plus 36. This is for the quadratic sequence. Now, in the first difference here, we notice that we have like 28. The first difference forms an arithmetic sequence. Okay, I'm gonna write it over here. First differences. Okay, I think I'm gonna write like this. Let's say the quadratic sequence here. Quadratic sequence. The quadratic sequence. We did get Tn was equal to -4n squared plus 40n plus 36. So as we did over here. Oops, I missed to write n over here. I meant to write plus 40n. So plus 40n. Okay. Now that was the quadratic sequence. Now the first difference of the quadratic sequence. Okay, the first difference of the quadratic sequence are formed are like 28. That 28. They are 28, 20, 12, etc. Okay. Now, so we said that the question says that the 12th term of this quadratic sequence is equal to the 12th term of the first difference here is equal to one of the term in the quadratic sequence. Now let's find the term. Okay, fine. Now first of all, we know that the first difference of the quadratic sequence forms an arithmetic sequence. Okay, you can notice that it has a constant difference of -8, as we did calculate earlier, -8. Now we can write Tn like this. I can say -8n, because this is the constant difference, and then I said to myself -8 plus what equal to 28. So you realize that this is plus 36. If you're unsure, use the formula Tn equal to a plus open bracket n minus 1 times d. Okay, and then substitute the values. The first term is 28 plus open bracket n minus 1, and then d is -8. And then this will be 28 minus 8n plus 8. And then that makes -8n plus 36. Okay, so now we will going to find the 12th term of this arithmetic sequence here. So therefore, I'll say therefore T12 will be equal to -8, okay, n plus 36. So wherever we have like n, we're gonna substitute by the value of 12. We can sub 12 here, and then that makes T12 T12 equal to -8 times 12 is -96 plus 36. That makes T12 equal to -60. Okay, so now this -60 is equal to a certain term, as the question says over here, a term in the quadratic sequence 72, 100, 120, 132 is equal to the 12th term of the sequence of the first differences. So determine the position of this term in the quadratic sequence. So the position is n. That's what I wrote here. Now we're going to substitute. We're gonna say like, I'm gonna do this. Okay. I wanna substitute. I'm gonna say, so we need T12 here in the linear pattern or arithmetic pattern is equal to -4n squared plus 40n Tn here. Okay, I need to move a little bit like this one, plus 40n plus 36. Okay, let me just write its value is -60. Okay, so it means that this -60 equal to -4n squared plus 40n plus 36. Now we can just write -4n squared plus 40n plus 36 equal to -60. So if I move the -6 over, that makes -4n squared plus 40n. Okay, it's gonna, if I move the -60 over, it becomes +60. So 36 plus 60 makes 96. So that's gonna be plus 96 equal to 0. Now what we see, we notice that each term here in the quadratic sequence is a multiple of -4 or 4, but I will divide each term by 4, by -4 I mean, and then this will be then n squared minus 10n 96 divided by 4, 96 by 2, 42 by 2 again 20, -24 equal to 0. Now we can solve this by factorization. I can just write n here and then close bracket there, open bracket n, close bracket there equal to 0. Now I'm gonna look at the last term, which is -24. There I'm gonna write like -24. Then I will list all the factors of 24, not -24, but the factors of 24 in ascending order preferably. So they are like 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then we stop there. Now, in the list of the factors of 24, there must be one and exactly one couple which will make a sum equal to -10 here. Now let's see. With 1 and 24, we cannot make it, neither this, neither this. Okay. Okay. With 2 and 12 can make 10. If I do can make -10 if I do +2 and -12. So will -4 and -6, because -4 minus 6 makes -10. But if I do -4 here times -6, that makes +24, but there we have like -24. So this cannot be the right couple of the factors of 24. Then I will take +2, okay, and -12. Now, remember the property in math that says if A times B equal to 0, then A equal to 0 or B equal to 0. So in this situation, when I say n minus 2, n plus 2 equal to 0, or n minus 12 equal to 0, then this means n equal to -2 or n equal to 12. Now remember that n here are only positive integers. Okay, so -2 is not acceptable answer. The correct answer is n equal to 12. Okay, the following question says what? Let's see then. The following question is over here, 2.1.3. The question says determine the maximum value of the quadratic sequence. All right. Okay. Well, this concept must be the same as the one of quadratic functions. Okay. Remember, of same concept of parabolas. So we can determine the maximum, like, because all quadratic equations are parabolas. Okay. Let me just erase this. 2.1.3. So we want the maximum, excuse me, we want the maximum value of Tn. So maximum of Tn. So I was saying, to determine the maximum, this is what we can do. Either we find the derivative of Tn, because Tn here is like the function now, because the variable is n, the derivative of Tn. We can also solve this by, okay, I'm writing formulas. So to find the maximum of the function, we do the derivative. We set it equal to 0, okay? Or we can also say x is equal to minus b over 2a. This determines the line of symmetry. Or we can also find the average between the intercepts, okay? This would be like x1 plus x2 over 2, where x1 and x2 are just the intercept. Those are the three ways we can determine the maximum of a function. Now in this situation, our function is Tn, okay? Which is given by, it was given by 4n squared plus 40n plus 36. So we are going to differentiate this function. We can do a Tn derivative. This would be negative 8n squared plus 40. Okay. So you remember the law of differentiation. So if in case someone struggles with that, this is what we can do. Tn derivative will be equal to negative 4n squared derivative plus 40n derivative plus 36 derivative. Okay, we differentiate the whole function. Now this will be the rule says if you have like a x to the power of n derivative, this is just equal to a times n times x to the power of n minus 1. This is what I'm going to apply here. So this is going to be like negative 4 times 2. My n is 2 now. Okay, times n to the power of 2 minus 1 plus, remember, when you don't see any exponents and the same it's 1, so it's going to be like 40 times 1 times n to the power of 1 minus 1, and then the derivative of a constant just 0. Okay, so plus 0 there. 36 derivative is 0, and then this will be equal to negative 8n plus 40 because 1 minus 1 is 0, and then n to the power of 0 is just 1. 40 times 1 is 40, and then that's Tn derivative. Now we're going to set this equal to 0 as the function, as the formula says. The function, the derivative of the function is set is equal to 0. So if I move negative 8n over, that makes 8n equal to 40, and then we can divide both sides by 8. Okay, we divide by 8 both sides. to find n, I divide by 8, I divide by 8, and then n will be equal to 5. So this tells us that the fifth term generates the maximum value. Okay, so if you need to find the maximum value, then we will going to work T5. Okay, so it's going to be -4n² plus 40n plus 36. So instead of n, we sub 5. So 5 there, 5 there. This will be like 5 squared is 25. -4 times 5 squared, that makes -100. Plus 40 times 5 is 80. And then plus, actually, my apologies, 40 times 5 is 200. And then plus 36. So this will make -100 plus 200 is 100. 100 plus 36 makes 136. So this is the maximum value. Okay. So what we did, we first differentiate the function, and then we set the derivative equal to 0 according to this formula, and then we solve for n. Someone else may use this other formula of the line of symmetry. We can look at that was method. I can put method 1. Method 2 would be like this is still 2.1.3. We can say x equal to x1 plus, actually, line of symmetry, we say x is equal to -b/2a. Our quadratic pattern was given by Tn equal to -4n² plus 40n plus 36. Okay. Now this formula is for quadratic equation, which is of the form ax² plus bx plus c. Remember that a is the coefficient of the x², b the coefficient of x, and then c is the constant term. In this case, a is -4, and then b is 40, and then c is 36. Now we can work out n. The variable here is not x but n. N will be equal to b, which is 40 over 2a, negative signs there, 2a. A is -4, and then this will make -40 over -8, and that makes n equal to +5. And then we can notice that, as we said, when we sub n5, T5, we calculated earlier, T5 will be equal to 136. We sub T5 in the quadratic equation is 136. Or else, we can also work out the intercept. Okay, we set this equal to 0. We find the variable, the intercept. I'd like to do it. Or we can also do like -4n² plus. Okay, I prefer to say this. 2.1.3 method 3 is like we're gonna use this formula: x is equal to x1 plus x2 over 2. Okay, knowing that x1 and x2 are the intercepts, so we're gonna set -4n² plus 40 plus 36 equal to 0. Okay, so if we divide each term by -4, okay, because I want to get rid of the coefficient of n². Okay, that's going to be n² minus 10n, that's 40n, minus 10n minus 9 equal to 0. Now we can solve this by factorization. And I look at the constant term here is -9. So if I do -9 here, the factors of 9 are like 1 and 9, and then 3 and 3. So I'm gonna ask myself which couple will give me -10 here? So we can see with 3 and 3 we cannot, but with 1 and 9, yes, we can. If if it was negative with it's gonna be -1, but I cannot say -9 here because -1 -9 will make of course it makes -10, but -1 times -9 makes +9, but we have -9 there. So this equation is not factorizable. If it was factorizable, we will see the factors and then we will see the intercept by using the factorization method, and then we find the average. Or we can still use the quadratic formula. The x is equal to -b plus minus square root of b squared minus 4ac over 2a. Just because the intercepts are surds, they are like the irrational numbers. If you do that, you find the average. You're gonna get n equal to 5, and then substitute there. So thank you. Yeah. The other question says, okay, maybe I can just show it. Should I? I don't need to. Okay. Question 2.1.4. This question. The question says that determine the maximum value of the sequence -23, 5, 25, 37, etc. The maximum value of this sequence. All right. Now, let's see. Move my board over here. 2.1.4. So we want the maximum value of the sequence -23, 5, 25, and 37. Okay. I cannot ask us the maximum value of this yet because I think there's a mistake here in the paper, in the question. I think there's a mistake, okay? I think they meant to say determine the next. That's what they meant, because for one mark here, it cannot be the maximum because there's kind of a lot of work to do. So I think they meant to ask for the next term, but if it was the maximum, we're going to apply the same technique we did in question 2.1.3. So here it was, my guess is they ask us for the next term. So because this is like term 1, term 2, okay, term 1, term 2, term 3, term 4. So we're looking for term 5. We need to find. So what we do in this situation, you know, we're gonna find the difference between these terms, okay, this and that, and then 5 minus 23 is 28, and then 25 minus 5 is 20, 37 minus 25 is 12, and then we're gonna find again another difference here. Okay, that's gonna be -8. It's similar to what we did earlier, -8. Now the second difference in the quadratic pattern is always constant, so here it's also -8. So I need to find the term in the first difference here. How can I get it? I'll simply do 12 plus -8, which is 4. So here the term is 4. Then it means that 37, to find T5, then I'll say 37 plus 4, which is 41. So T5 is 41. Therefore, okay, therefore T5 is 41. So that's the solution. Okay. Thank you.